Hello, welcome back to another Timescale stream. So after yesterday's fumbling around with trying to get Timescale to work, I've gotten the data exported from my old Postgres server and imported into the new Timescale database. And today I'm just going to kind of play around with the server, comparing metrics between runtimes, sizes, inserting, querying, that sort of stuff, and just playing around with the different knobs that Timescale allows me to see if it can be improved to the point where it would be viable replacement or a good replacement for my vanilla Postgres server that I currently run. So let's go ahead and take a look at that. So yesterday I left off with basically I had the Timescale database up, but I didn't have any data in it, and to get the data in it would have taken probably a bit of time that I didn't want to do on stream because it's kind of like this boring little dance of exporting the data, importing the data, and just waiting, a lot of downtime. And so that's what I did today. I exported the data from Postgres and then re-imported it into Timescale. So here's currently like XQC's viewership numbers, right? You can see the old ISO week format that I've been using versus the new TimescaleDB with the actual timestamp, timestamp with time zone to be specific, that it has. So this is the same data. Only difference is this is running on Postgres 13, whereas this is running on Postgres 11. So that's how you can kind of tell the difference. Also, you can see Streamerverse versus Postgres. I'm just using the default Postgres database versus my custom Streamerverse database that I made. So I've already run this once, as you can already tell, and just based off of this first run, this takes a second, 2 seconds to query all the data, whereas this takes half a second. So right there, I can already see some issues that this is slower. This is just straight up slower than this. One thing I should note though is that I've really optimized this. Like I have an index that quickly searches by ISO week and streamer ID. So that's why it's very likely why it's a lot faster. Versus this, which doesn't have an index on streamer ID. It just has an index on time. So so to be fair, it's a minute and a half for just an index on time, versus this, which is a minute or half. I keep saying a minute for some damn reason. I'm operating in seconds here. This takes half a second to fetch with an index on both these values. So it's not bad. Based off of that, that's not bad. And there's a couple things that I can do to improve this. One, simple enough. Make an index that encompasses both these values, just like I have on Streamerverse. The other option, which I've been thinking about, because I was looking at the docs today for Timescale, and one of the things that it allows is to create it allows to partition on a second column. And here in the docs, you can see hypertables. Is this the right one? This might not be the right one, but if I go to core concept hypertables, you can see here a hypertable can be partitioned by an additional column or columns as well, such as device identifier, server, container ID, user, customer ID, location, blah 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 blah. Just some other column that it can partition the chunks by. Because right now all it's partitioning the chunks by is the time. So I have actually, I already looked this up. I'll show it to you. I can show it to you guys. Give me the connection. Oh. Query tool. Show chunks. Viewers. I've got 3 chunks. So each one of these chunks is actually just a different date. So this is I imported 3 weeks of data. So this is week 18, if you want to think about it. This is week 19. You can see there the first run is always slower, but consecutive runs do get a bit faster. This is week 18, and then there's week 20 as well. So there's 3 weeks of data in this, so which corresponds to the 3 chunks here. So each one of these chunks, as it kind of shows right here, is a different timestamp in the hyper table, which is just an abstraction on the chunks that are below it. So I can partition the hyper table or the chunks per se by not only the timestamp, but also by the streamer ID. So instead of only having 3 chunks, I'd have 3 times however many streamers I have, which I think is like 1,000. So it'd be like 3,000 different chunks in that it'd go across. And that would honestly, that would probably speed up the database quite a lot. Like, I imagine, like, insanely fast, because it wouldn't have to go through so much random garbage. My only concern is finding chunks. Like, I don't know how good it is at determining where chunks are, because like all these chunks are just files on a disk, I imagine. I think that's how they do it. Each chunk is a file on a disk that gets read by Postgres and does all its fancy magic. So either I can do a partition on the table for not only time but streamer ID, which will make a lot of files on my disk, or I add an index, which is a single file, just a really big file that basically keeps track of where everything is. It kind of knows, like, oh, okay, so time here, streamer ID here is in this chunk at the kind of like this far down, that kind of thing. Like, it knows where to go. So I'm still debating internally which one I want to do, and I'm not actually sure if I can reorder a table. Like, I'm not sure if I can take a hyper table and just reorder it, or like kind of configure it again. I didn't really check that out. So right now I think what I'm going to do is give the other query that I kind of always like to use, which is, what if I were to have Postgres just do the comparison of viewership for me, instead of having to like pull all the viewers out of the database, then let Golang compare it. Will it be faster if I let Postgres do this? So let's go ahead and give that a shot. Let's see how long this would take. From viewers where, so week equals 2021, week 18, and streamer ID is in XQCOW. This is like my standard kind of test, because XQC and Riot have really big viewer numbers. So this is kind of an easy way to find out how performant the database is in my mind. A good snapshot, a good litmus test. So group by ID, having count streamer ID. So we group by the user, the viewer, and then we count each streamer that's in that group. Because if there's 2 streamers in one group, that means that viewer is shared. If there's only 1 streamer in that group, well, then they're not shared. They were only in one of the 2 chats and not in both. And so we can go ahead and run this. And right, it always needs to be called something for some stupid reason. I don't really care what it's called because I don't use it. And this query takes a bit of time, but 48,000. So there's 48,000 viewers that were in XQC's and Write Games' chat during this week of 2021. Now, what happens if I were to do the same query, but on the hypertable? It's going to be slower, I imagine, because again, this has an index that it's able to go against versus this. But let's see. Oh, right. Time equals... Actually, let's go back. 9. Gotta copy. Actually, let's copy this. And instead of just replacing it, just do that. Copy. Time. Delete this. And this should be week 19, just the same as this, because 6 is 18. Oh, no, 2 is 18, 9 is 19, and 16, day 16, is 20. I think that's how it inserted it. I don't know how it determined those dates. I just let it decide for itself. So they just had to be a week apart, in which they are 7 days. So let's see, how long will this take? So how long was this again? Just to refresh, let's see. A second, 1.1 seconds, and this is gonna take. This is gonna take. Again, it's gonna be slower the first run. This took 3 seconds, okay, and then if I run it again. About the same, yeah. I wonder, let's see, what happens if I were to create scaling? Oh, this is just for multi-node things. I don't care about this really. Hypertables. Let's see, I'm trying to, I think I'll start off with creating an index. Let's see what will happen if I create an index, because this wouldn't take up as much space on my drive, because again, that's 3,000 different files for 3 weeks of data, basically. Or actually, that's not true, because it's like I don't know how many. Find out here. Let me log into my live database, and I can find out exactly how many streamers there are right now. There's 3,000, and that's for 1, 2, 3, 4, 5, 6, 7, 8. 8 weeks of data. 8? No, 7 weeks. Sorry. 1, 2, 3, 4, 5, 6, 7. Yeah, I miscounted. And week 24 just started, so this one's basically empty. But all of these this through this is currently what's on the live. These 4, 18 to 21, is currently what's on the live server. And so 22, 23, 24 are what are being collected for June. I plan to release the next one probably around this date, June 2nd, because on the 27th it'll finish collecting another month's worth of data. So that was the 30th, 31st to the 28th, I think, is the range it'll collect for. So I don't think this change will go live in the next one, or in V2 of the graph, but it might come out in V3, depending on if I can get this right. Like, let me just do a quick Google search. Let's see, TimescaleDB index. Indexing. Okay, cool. They got something. Supports the range of PostgreSQL types. Creating an RL range will be similar from. Will similarly propagate it to all of its constituent chunks. Data is indexed via, for instance, create index on conditions. So conditions is their sample table. It's a really shitty name in my opinion, but whatever. So on table conditions with location and time. This can be done before or after creating or after converting to the hypertable. For sparse data where a column is often null, we suggest adding where column is not null clause. No. On your data for indexing data columns with discrete. With discrete. Where was I? Fuck. Here. Limited cardinality values where you are most likely to use an equals or not equals comparator. Okay, this is kind of right, because like, this is kind of similar. Maybe I'll try creating this kind of an index. For all other types of columns, that use columns with continuous values where you are most likely to use less than or greater than. No, I use this. Specification. The index allows for efficient queries by column value and type. For example, the index defined above would optimize the following query. Okay. I understand why composite indexes should be defined in such fashion. Consider an example where two locations are office and garage, various timestamps, temperatures. An index on time would organize in a sorted fashion. One can think of an index as B trees as being structured from the most significant bit downwards. Additionally, if the create command specified additional space partition in addition to time, say the location column times long. Okay, so so I guess if I had done an additional partition column, it would have done this index. I would not only have different chunks, but I'd have different like a completely new index. Alright, let's try creating an index like this and see what happens, because I can delete indexes easily. They're of no consequence to me. I can delete them and add them at a whim. Whereas if I try to reorganize a hypertable, I imagine it's going to be a little annoying. Let me close down some of these so I don't accidentally delete live data. That would suck. Query tool. Okay, so let's paste this on viewers. I guess I could have also, like, viewers has properties, has a primary key. Does it? Should. Table, viewers, constraints. No? Really? It doesn't. Oh. It doesn't have a primary key. Interesting. Wonder how that works. I think it doesn't. Let's see, refresh this. It doesn't have a primary key. Look at that. No primary keys. That's very interesting. I guess another thing is I haven't run vacuum on viewers. Maybe if I ran vacuum on viewers. I don't know if I should though. I don't know if that's a good thing to run on it. I'll give it a shot. See what happens if I run it. Hopefully it doesn't break something. I don't know how to spell vacuum. Fuck, there you go. Vacuum. That's a weird fucking word to spell. Vacuum viewers. This is 13, so yeah. See what happens. Okay, it did something. Before I go ahead, I'm just gonna try that. I'm just gonna try the basic query again, just to see if that actually did anything. I always fucking forget this. It's really annoying because now I can't just easily remember what the format is, because Y year dash W week is such an easy format to remember versus that like long timestamp. And then let's boost that to 9. How long will this take? A bit faster, but still not that fast. Alright, so let's go ahead and try and create this index. Let's see what happens. So create an index on viewers where streamer ID and time and in descending order. Don't really care about the descending, but let's give it a shot. Probably take a while, I imagine, to create this. Let's actually check out my computer. Oh, blessed 60%. What's doing that? Yeah, it's the Postgres server that's just shit in the wall right now. I love it. Okay, well that runs in the background. I'm just going to continue reading about this sort of stuff. Because, hey, if this turns out to be faster than, what, a second, a half a second, kind of, I believe, then this could be really beneficial. I could finally have my live database or live view of the database. And another thing, this actually I haven't really talked about, but it is a good benefit, is it actually has something called continuous aggregates. I believe this is the create a continuous aggregate. So what this does is it basically creates a view on top of specific types of queries that you want to run that would be very costly to run on demand, but you can run them ahead of time and then just save that save the result, so that when somebody comes along and asks for the data, they'll just be served up a cached version of it, which actually would be really helpful in the case where I try to aggregate all of the viewers to streamers. Because before I can do anything, before I can like even start to check compare viewership, I have to fetch all the streamers and all their all their viewer counts from the database. And doing that initial fetch actually takes a bit of time. I think it's like 5 minutes. No, not 5 minutes. So that would be god awful. Jesus, I think it takes like a minute or maybe a little less than a minute, and that sucks. That's almost that's 1/5 of the runtime of what currently takes. So if I can create a view or a continuous aggregate on that initial query, instant, won't even do any problems. So this would be it would completely eliminate my problem with the first query, which would be amazing. So if I can get the hypertable to be as performant as my Postgres server, just the mere fact that this continuous aggregate exists probably would push it over the edge to be worth it to do it over my vanilla Postgres server. Because, again, it takes like 1/5 the time just for that one query, and having this continuous aggregate would just completely reduce it by like a minute runtime, which would be great. And so hopefully, I don't know if this has come across yet, but I'm actually kind of rooting for Timescale. I think it would be better, and I'm trying to make this work as best as I can. It's not like I set out to make this fail. Like, I didn't have the mindset that, oh no, I doubt this will be better. No, I hope this is better, and I think this is better. So I'm going to try as much as I can to make this as good as possible, or even better. And without obviously blowing like disk usage out of the water. Because like, as I said, if I were to chunk it also by the streamer ID, this would be so fast, but it would just take up so much space on my server, I imagine. And like right now, let's see, how much space do each of these partitions take up? Will it tell me? I don't know if it'll tell me. I know I can do it like this. Or no, let's do it like this. SQL or statistics. So like this is 2.1 gigabytes, or yeah, 2.1 gigabytes looks like. 2.6, 2.6, 2.4, 2.4, 2.4, and this is new, so obviously it's really small. So right there you've got 2.5, 5, 7.5, 9, or not 9, sorry, 10, 12.5, and 14.5. So 14.5 gigabytes is currently being used up on my disk, which isn't bad. So there you go, that created. And if I were to go, so it's 14.5 gigabytes is currently being taken up on my database, or on my server, and I have like 16 terabytes. So that's not a huge deal to me, but I don't know what the sizing requirements would be if I were to split up the entire hypertables by also Streamer ID. I don't know how big that would get. All right, so now we have two, Streamer ID and time. And now let's run vacuum again, because I feel like that would, I think that's necessary now that we just create an index. Maybe not. Okay, so now that we have it, let's give it a shot. Let's see what happens if I were to fetch from viewers. I'm also using a new background music right now from C418. He's the guy who did the Minecraft music. I was recommended to me on a whim from YouTube, and I've just been enjoying his music. It's so good. I loved Minecraft's music, but just his actual like regular production music is so nice too. Like I love the fucking beeps and boops. Time. Fucking Christ. I always forget what the stupid format is. I really should just remember it or copy it somewhere so I don't have to forget, but like, it's so fast to fetch, like I don't really care. Where and streamer ID is equal to XQCOW. I wonder if I have to order this differently in the query to make it better. Like, let's see. Core concepts? No. API reference? No. Timescale? I don't know where it was, so I'm just gonna Google it again. TimescaleDB indexes. Under schema management. Ah, I see. Having time is fun. Looks like it might be better to have it on that. Have the location first, but I'll give it a shot like this, and I'll change it around. So actually, before I do that, let's run this query on here. Come on. Here. Query. Let's run this on here. And change this. Y 2021 week 19 and ISO week. Change this to 9. The reason why I'm not doing week 18 is because week 18 is a bit smaller, so I'm using 19, which has a little bit more data, to just try to get a better view of the performance. So this takes around 1.1 seconds. This takes, drum roll. Holy shit, that was faster. Ooh, I think we might have found our winner. If I run it again. Yeah, okay. Let's view the planner. I think I'm about to sneeze. Oh, fuck. Oh, I hate that. I hate that when you have to sneeze and you don't sneeze. It's so fucking annoying. Let's check out the planner. Let's see what it did. Okay, that didn't help me at all. Thank you. I guess I can look at the planner for this at least. I think I have to use a custom planner. Yeah, use the primary key to search it, and that was about it. Thing is, though, in the live server, I don't actually just search by 1 week. Oh no. I have to do, the actual query is something like this. This is the actual query. So, how long does this take? .6 seconds. Okay. And then how long will this take? I believe that's right. I don't know if that's how you do the between statement, but I'll give it a shot. Looks like that worked. 1.01. How much was this? Yeah, same. This is 1.5 seconds, and this took 2.1 seconds, and it's slower. It was slower. So the individual query was slower. Can I see anything here? Or is it just going to tell me garbage again? Yeah, it's just going to tell me garbage again. The slowest part was just aggregating it. Like, searching it was fast. What about over here? Yeah, it was pretty slow. Aggregating was the slowest here as well. Because it's a lot. It's a lot of data to aggregate like that. Okay, maybe if I don't have to return it. What happens if I were to do the other query that I've been trying to wiggle my way into using? I got a little loud there for a second. Hopefully that wasn't too loud on the stream. From viewers, where time is between this and this, between 16 and 2, and streamer ID. Actually, let's just start off with something simple. Let's just do one time. Group it, and then we check if it has streamer ID is equal to 2. Alright, so we get all the viewers for XQC and Riot Games on May 19th or May 9th. We group them by their viewer ID, and we check each group to see if it has a streamer ID count of 2. If it does, then we return it, and then we count all the ones that returned. Let's see how long this takes. That was faster, but oh no. Can I do this? Let's see. The aggregate probably was the slowest again. Yeah, aggregating again was slower. And then the problem is that it's not only that, but I have to do this. Like it was what was it again? It's like 1 point something seconds. It's 1.3 seconds, and then I have to do this 4 times essentially if I were to do it independently. Or let's see, what happens if I were to do it as one? Which was another nice thing about this is I can do the between. I don't have to use the stupid like in for the time. Count distinct streamer ID, because now there could be more than one of the same streamer ID per group. So I have to make sure you're only counting streamer IDs distinctly. And how long will this take? Five seconds. That's slow. Versus this, which took 1.4. The slowest thing about this is still the aggregation. Wait, that was faster? Wait, what? What? Nutty? This all of a sudden got really fast. I think the database might have just optimized itself. Okay. But it's still, the slowest part is still the aggregation, isn't it? Yeah, like it's 40, like it was pretty slow on the aggregation. I wonder if I could, continuous aggregates? Could I use that? That's so many. No, I couldn't do that. That'd be way too many aggregates to have. Like I don't know what the recommend, like how many aggregates are you allowed to have on Timescale? Like what's recommended? Like am I allowed to have like 3,000 different aggregates? Is that allowed? Is that pushing it? I don't know. I hope it's like if it's fine, then I could do an aggregate, and this would be super fast. But damn, okay, this looks to be faster, especially after it's done some optimizations in the background. I don't know what it did. Let's try like Riot Games, which hasn't probably been optimized. Let's see what happens. No, Riot Games is pretty fast. Aiden Ross. I don't know who they are, but I always see their name pop up. That was pretty fast. What about something obscure? Trash taste podcast cast. Is that not how you spell their podcast? I don't know. Okay, maybe something else then. Something like CDog VA. What about him? Holy shit, he was super fast. What about over here if I do CDog VA? That's almost double. This is half of that almost. This took 88 milliseconds. This took 100 now it's 100 milliseconds. But this is faster. Damn. I think it's worth it. I think I've come to the conclusion it is worth moving my database into Timescale, having a continuous aggregate on the because like here, actually that's a good idea. Let's see what that would look like. So this is can select streamer ID count ID from viewers where streamer or where time is between and 16. Is that the query? Let me open up the project. Let's go new window. Or it's not Streamerverse. Damn it! Sorry, it's cluster. Cluster's the one that does that. Where is it? Where is it? I believe it's under. Here. Here it is. So this is the default one. Right, I have to join it to get the name, but I'll leave that out of it and just do this for now. So so this takes do I have 2021 in here? I don't think I do. So that's kind of a useless date, isn't it? I don't have 2021, so this is doing nothing. So how fast is it otherwise? Okay, it's still the same, so I wasn't really messing any of the metrics up. I didn't see how long this took. Fuck. How long does this take? Took around 12 seconds. Okay. And then if I did the join and everything, that would probably take a bit longer. And then what's it like over here? Holy shit. This is so much slower. That was a whole fucking 7 seconds slower. Oh my god. And I can just imagine the joining. Is this on my server? I'm not even entirely sure where I'm connecting from. Let's just see. Let me make sure I'm not connecting from my server right now. No, okay, it'd say at server. So this is definitely my local. This is definitely my local instance of the database. But that took 19 seconds. If I run it again, actually, let's see if it's faster. Because to be fair, I ran the other one twice. Doesn't look like it. I think it's just about as slow. 2 seconds faster, but still, it's not as good as this. This was 12. and it will be even faster if I add in that the aggregates, continuous aggregate. It just gets slower for some reason. Oh, that sucks. $20 seconds. Oof. The big oof. What happened? Why did this get so slow? It was 12 seconds, then it just dropped down to 20 for some reason. Is it reordering something in the background? I can take a look at the planner, I guess, see what happens. That was 15, so I got faster, but okay, so sequential scans, yeah, kind of expected that. But like, if I add in continuous aggregation, so I'll quickly read out what they call it. Aggregates are summaries of raw data. I'm summarizing some raw data here over a period of time. Some examples of aggregates are the average temperatures per day, the maximum CPU utilization per 5 minutes, yada yada yada. Calculating aggregates on time series data can be computationally intensive. You can clearly see that here with the aggregation taking almost 3.3 seconds. Like, a lot of the time was spent just on aggregating. Large amounts of data which need to be processed in order to calculate and recalculate aggregates over a period of time. Moreover, calculating aggregates while simultaneously ingesting data can cause slowdown in ingest rates due to the computational resources being split. That's another thing I don't really touch on here, is that while this is all running in the background, there's actually data being inserted every hour into this database. And if I'm lucky, or if I'm unlucky, and I hit a read when it tries to read from the database at the exact same time as it's trying to write to the database, oh man, my server is going to get hammered. So having something that can be cached and easily served up without just hammering my database is like a win in almost every scenario. Continuous aggregates solve both these problems. Are automatically refreshed materialized views, so they massively speed up workloads that need to process large amounts of data. Unlike in other databases, your views are automatically refreshed in the background. This is something that is not in like standard Postgres. Like, I can create a view in Postgres, but I can't have it refresh the view unless I manually go in or create some weird ass job to do it. Like, what's nice about Timescale is it's a first-party solution. It's integrated right into the extension, as it were. So I don't have to do some weird magic bullshit on my side just to get a view to refresh, which is great. Continuous aggregates automatically are automatic and in the background calculate and maintain the results from the specified query and allow you to retrieve the results as you would any other data. The views are automatically refreshed in the background as data is added. Postgres users familiar. Yes, so as I said, if you're familiar with views in Postgres, it's basically that, but unlike in Postgres, it actually refreshes on its own whenever you need it. And you don't have to do it manually. Yeah. So creating it is basically you create a view like this. So I could do that right now actually in this. I'll do it, why not? So let's see. So create materialized view. What do I want to call this? Streamer viewership weekly with TimescaleDB dot continuous as select streamer ID and count. Do I have it still? I don't. Damn. I have it right here though. Thankfully, I don't have a lot of metrics to calculate. I'm gonna do it this way, the way I'm used to doing it. Viewers. Group by streamer ID with no data. Okay. Okay, so how do I make it do it weekly? So it's doing it daily here because it's doing the time bucket, 1 day time as bucket. Wow, that was some loud pitch right there. I don't know what this time bucket function it's using is. Notice how we use our friend time bucket from the previous section. Let's go back, I guess. Jesus. Used for analyzing data over arbitrary time intervals. Used for finding the earliest value. Used to analyze data over arbitrary values and fill in any gaps in the data. Used to fill gaps in data by carrying the last value. Let's try time bucket and see what it looks like. This is a more powerful version of the standard Postgres data truncated function. Jesus, calm down there. That fucking high-pitched squeal it does sometimes. It allows for arbitrary second, minute, hour, etc. provided by data trunk. The return value is the bucket's start time. Below is necessary information for using it effectively. Oh, okay. So timestamp and the bucket width. Oh, okay. So I can just do. If I go back. Nope, too far back. Here we go. What I can do then is I can go time bucket 7 days, or I guess I can do 1 week, perhaps, with time as bucket, and then we do bucket and then we would get bucket streamer ID, so we group it by the bucket and streamer ID, and then that way the view will be calculated on a per week basis, and it'll automatically refresh this every time there's a new view for every week. I think this would work like that. Jesus, this song's got some really high-pitched notes in it. Hopefully it doesn't come up too badly on the stream. Like, I've got it turned down on my side and on the stream, so hopefully it's not like just jarringly high pitch. Here comes another one, let's see. No, not really. It's staying around negative 30 decibels on my side, so hopefully it doesn't come up too bad on the stream. Let's see. Okay, so with no data, that we want to specify the date by bucket by the day, 1 day time periods. You can create multiple conditions in the same method, but for simplicity, we'll just create one. 6 month aggregates for all metrics for a specific city. Okay, so yeah, you can use the time bucket to bucket it by certain intervals. If you ever need to inspect details about a continuous aggregate, such as its configuration of the queries defined, you can use the following. Okay, cool. Now we create the, but it has not materialized. Okay, so if I run this, it won't actually do anything. I'll just create the view, but it won't actually populate it. So you can manually refresh it, and then you can add an automatic policy. Okay, query. So query all. Okay, so right here we're refreshing the data between, or the daily metrics between 2010 January 1st and 2021 January 1st. Okay, that's interesting. So you can tell it the range to which to refresh by. Alright, let's run this. Let's see what happens. I'm on the right thing. Okay, I created the view. And let's go ahead and take a look at it. Okay, we have one view. Streamer viewership weekly. Materialized only, false. Internal, hypertable 2. I wonder what the first hypertable is. And this is the definition. I can't really see it though. But okay. Now, let's try refreshing it, I guess. So, streamer. Why is my insert on? Okay, for some reason, insert decided to turn on. Streamer. Viewership. Weekly. Between 2021. Oh, what the hell is it? Actually, keep that up, just in case. Close that again so I don't... Is this the server? No, it's not the server. Always gotta be careful because I do not want to mess around with the data that's on the server. Let's see. So between May 1st and June 1st. Let's see what happens. It should create a couple separate views. Okay. Probably will take a while, but when this is complete, I should have 4. Yeah, no, I should have 3 separate views because I have 3 chunks, so it should have 3 separate views. Right? Yes. It should. Hypothetically. Okay, while this runs in the background, let's go ahead and read more about the automatic policy that I can set up. So this is what I'll run after, something similar to this. But an automatic policy can use refresh continuous aggregates according to a schedule. For me, it'd probably be like every week, or yeah, every week. While many databases have ad hoc capabilities for managing large amounts of time series data, adapting these features to the rhythm of your data lifecycle often requires custom code and regular development time. Enter Timescale's built-in background jobs. Yeah. Using automatic policies for updating continuous aggregates is the first of many. Timescale has also policies to automate compression and data retention. So compression probably would be good, but I don't have any sort of like read replica nodes, so this doesn't really matter to me. Maybe I can create a backup. I could export a backup, but okay, there you go. Let me finish this, I guess. Where was I? Create custom policies and data. Where's data retention? There it is. You'll see policies for compression later. Okay. So this is how you'd create it. So you set the interval. I don't know what to start off. Refresh the last 6 months of data every 2 weeks. Okay. I don't know what end offset is. And 1 hour. Okay, when it runs, it will materialize data for between 6 months and 1 hour of the time. Oh, okay. So between here, okay, so you could set it to now or in the future if you somehow have future data, but like obviously I don't have future data, so. But let's scroll back up. I should have, in theory, 3 separate views. Okay, so from weekly, where, or I don't care where, let's just order by bucket in ascending order like they ask. So there should be 3. So there should be 3 returns on this. Hope to God this works. Wait, how much was this? 4,126 rows? Oh, that's right. It's because it's not only by bucket, but it's also by streamer ID. So it's actually not 3 views. There's 3 times whatever. Well, it's 3 divided by 4,000. So what was it? 4126 divided by 3. A little bit more than that, but so there's about 1,300 streamers. So it created, essentially, it was one view that created, I don't know how many metrics. Or actually, it created, no, it created, You can see the bucket change right there. Let's see. Where bucket is equal to yeah, 1,014.34. Okay, interesting. So yeah, it created the view for each of them, and it like, honestly, that's pretty fast if you think about it. 82 milliseconds for 4,000 rows versus here when I have to do, like on this one, on this one, like it's already slower. But let's see, I think this is 20 seconds. For this 3, remember this is 3. There's another week that's missing from this data set, so it'd be longer than whatever is going to be returned here. And if I was inserting data at the same time this ran, oh god, oh man, that would suck. And this is for all 3 weeks, so obviously what I would do is I would say, oh, give me the buckets that are between where bucket between this and this, between 2 and 16. Like, this is what I would do. Like, I would say, okay, I want the data between these 2 weeks. Give me the buckets. Give me all the buckets, and then between this week and this week, then group by streamer ID, and then give me streamer ID and the radius, or in the sum of radius, like that. 82 or 76 milliseconds. It's probably even faster than that. That time is probably just my shitty hardware. Like, look at that. That's the entire. How many rows is this? 2,000. 2,000 streamers. Discord's in here. Discord has a Twitch channel. What the fuck? I didn't even know this. I need to see this. They have to be in my live data set if that's the case. This is all cached, I should mention. All this data that's being rendered here is cached on my backend. It's not actually live, which is a point that I want to fix. I want this to be live data. I want it so that I don't have to pre-compute it and then store it on my server and then serve it up. I'd rather it just be on demand with some caching. There has to be some caching at some point. But holy shit, they do actually exist. And they are part of just the generic kind of here area. Bob Ross. Call me Kevin. Is that what was that? Call me Carson's alt? Like what the fuck is that? So yeah. Okay, so this is looking good. This takes what? Less than that. It takes less than that. That number's bullshit. That is beautiful. And then obviously the real number, the real time would be like this. 423. Like that would be what I'd really have to do. And it calculates this weekly, because one thing that I want to try and do is maybe give people the option to do like weekly granularity. I don't know if I'll ever do that. So I might actually change the material view to be a month, because that's more indicative of what would happen, or not of what would happen of the time. So I might actually start out with a. Oh god, my wire's getting caught. I might. Can I alter? Can you alter real-time aggregation? What is this? By default, continuous aggregate support real-time aggregation, which combines aggregated data and raw data to create time for most up-to-date results. You can turn off this. Okay, that's cool. All right, and then I'd create this automatic policy, which I don't think I really need to do because it's kind of, yeah, cool. You just run this command with the different specifiers here, and you've got yourself a continuous aggregate. I wonder, can you modify? Create, alter, you can. Okay. I'm gonna alter mine. The command look like? Okay. Oh, you can't. You just have to drop it. Okay. I'll just do that. I'll just drop it. Drop materialized view, streamer viewership weekly. Hopefully that didn't just fuck something up. I hope not. That looked a bit sketch from what I was expecting. Okay, and what I actually want to do is monthly, 1 month time bucket security. Okay, well, that didn't work. Why didn't it work? Oh, you can't do, okay, you can't do month, you have to do 30 days or 4 weeks. I wonder, how does that work? So if I do, because a month technically isn't 30 days. It could be 30 or 31 days. So maybe it's better to do 1 week and then just aggregate it together. It's always 7 days though, so maybe let's just do 4 weeks. Let's see, 'cause that's a month. I know that's a month. 4 weeks is a month. and then query tool. Where's the call? Here it is. Copy. And let's change this to monthly. Run it. I guess we'll go back one. And this should create one bucket for the month of June, which isn't technically complete because it's missing 1 week. And then, yeah, let's see how this goes. So far this stream we've discovered that creating just an index is faster than what I currently have on my Postgres database. So that automatically rules in the fact that this is probably a better way to go. And I haven't even tried partitioning on the table, which I'd probably imagine would be even way faster if I did that. 2, continuous aggregates are cool and they're really helpful. They insanely speed up the runtime. And honestly, it's looking like all in all Timescale is the way to go. So I think what will happen is, and this is going to be annoying, but I'm going to have to export all of the data and then import it into a Timescale database that I'll have to create on my server. Thankfully, Timescale has TimescaleDB Docker. They have a Docker image, so I don't even have to do anything. Like, they already have a Docker image up. For some reason, they don't advertise 13, but I know it exists because if I go to tags, it's right there. They have 13 up, so I'll use 13, even though 12 is the only one they have on their README. I guess it's because it's the most up to date. 20 days ago, not really. So yeah, I can launch this Timescale Docker easy, no worries. Let's go ahead and actually just call the data. I don't even have to do this because it's already grouped for me. It should be 1 month already there. Yeah, 2000, as you can see right there, it's already aggregated for me for that 1 month that it exists. And let's go ahead and actually return everything. Let's see what the bucket looks like. I don't even know what that'd be. So this is the bucket. Okay, so the bucket started on April 25th. What does that look like? So if we go back to April, it started on April 25th, and it goes 1, 2, 3 weeks. Yeah, so that'd cover those 3. I'd probably, in real terms, have it start on, because my time starts at the 2nd or the 3rd, whatever you want to call it, and then goes 1, 2, 3, 4. So it actually encompasses these 4 weeks instead of these 4. So it'd be slightly different, but you get the idea. But damn, look at that data. Simple, clean, and optimized, I think, to a point of almost just ridiculously ridiculous amounts. Like, I don't think you can get any more optimized than this at this point. So yeah, I'm gonna have to move all this data over. That's gonna be fun for me to do. I probably won't stream that, obviously. But I might stream the hookup of, me hooking up the cluster to the new database, just to kind of show that, because I think that'd be fun to watch. And then the only thing left really for this month that I want to improve is the interactions. So I closed the page already. Yeah, I closed the page already, but I'll just open it again. Fuck, I don't care. So the next thing that I want to do, or the last thing I want to do this month for the graph, is to make another interaction. Because right now, searching, cool, people can do it, they're happy. But I want to add one more interaction where you can, I gotta wait till this stops moving. There we go. I want to add an interaction where you can go to your favorite streamer, you can click on them, and what will pop up is a little dialogue either somewhere up here or maybe an entire box. I don't really know. You click on it, and it'd have their image, a description, some stats that I maybe have, and a list of the most similar streamers to them. Streamers that they're highly connected to. Like for XQC, I imagine that's so many. But I think that is a good interaction to have for the site that people can enjoy and look at. And once that's complete, the next step I think is YouTube. After this month, I think in July, I'm going to do YouTube. And oh god, I've been looking at YouTube a bit in my spare time, and it does not look fun. They do some weird shit with their chat. I'll tell you that. I'll probably go into it more when I actually start it, but I'm not really looking forward to it. And I don't even know if it'll be viable, to be honest. I'm concerned that it might just be a dead on arrival. But until then, I think that's where I'll call it quits for today. Thanks to anybody who's watching the stream. Appreciate it. Links in the description for V1 of the project if you want to go check it out. If you have any comments, feel free to leave them. I can sure to respond if they have any questions. And go check out C418. I was using his music during this stream. I really like it. Hopefully I don't get copy striked by him, but if he does copy strike me, he can take all of my $0 because I used his music. I liked his music though, so hopefully my $0 go to some better benefit for him. But that's it for this week. I'll see you guys next week with probably some more programming. Bye for now.